Have you ever seen an AI learn to master a game and just wondered, how? Well, a huge piece of that puzzle is something called Q-learning, and today we're going to crack that code together. Don't worry about the complex math, we're going to build a really simple, powerful intuition for how it all works. Let's dive in. So here's what we're going to cover. First, we'll talk about the why, the big problem that Q-learning solves. Then we're going to use a simple analogy to make it all make sense. After that, we'll look at the secret ingredients, see how they all work together, and then wrap up with the one big idea you should take away from all this. Okay, so let's start at the beginning, the learning dilemma. Before we can really get into how Q-learning works, we need to understand the problem it was designed to fix. And here is that problem. Think about it. When you're learning something new, you have to explore, right? You have to try new things, mess up, and see what works. But at the same time, you want to use what you already know to do well. So the big question is, how on earth do you learn the perfect strategy when you're still in the middle of that messy trial and error phase? Well, the answer is this really clever idea called off-policy learning. This is the magic trick. It lets you separate the acting from the learning. It means our agent can be learning about the perfect master-level strategy, even while it's still acting like a total rookie, making all sorts of mistakes. And this is the absolute heart of Q-learning. Now, I know that still sounds a little out there. So to make this really stick, we're going to use a simple analogy for the rest of this explainer, the quest to cook the perfect steak. So on one side, you have our learning agent, the rookie chef. This is what we call the behavior policy. He's in the kitchen, he's trying stuff, maybe he adds too much salt, maybe he flips the steak too early, he's exploring. On the other side, we have our goal, the master chef. This is our target policy. He represents the perfect, flawless recipe. Q-learning is what allows our rookie to learn the master's recipe just by paying attention to his own clumsy attempts. So how does the rookie actually pull this off? Well, it all comes down to a few secret ingredients. Let's break them down, one by one, using our kitchen analogy. First up is something called the Q table. The easiest way to think about this is just as the rookie chef's personal notebook. In this notebook, he's going to keep a score for every possible move he could make in any situation. It's basically his cheat sheet for answering, how good is this idea right now? And this is kind of what that notebook might look like. The rows are the situations or states, like having a raw steak or a hot pan. The columns are the actions he can take. And those numbers inside, those are the scores, the Q values that tell him how good each move is. A high score, like a 9 for flipping a sizzling steak, means that's probably a great move. Now, when our rookie starts out, this entire notebook is totally blank. So, how do those scores get filled in and updated? That's where the update rule comes in. And this is the really clever part. The rookie doesn't just learn from his own result. He updates his notebook by looking ahead and thinking about what the master chef's best next move would have been. Let's walk through it. 1. The rookie tries something, maybe adds butter. 2. He sees what happens, gets a nice sizzle, a small immediate reward. 3. And here's the off-policy magic. He peeks at the master chef's recipe and asks, okay, from this new sizzling steak state, what's the absolute best thing the master would do next? And 4, he uses that information to nudge his own score for adding butter to be just a little bit closer to that perfect future outcome. All right, we have all our ingredients. Let's actually watch the rookie cook for a minute and see how this all comes together, one step at a time. Okay, so our rookie's got a steak in a hot pan. His notebook is still pretty new. The scores are kind of random, so he just decides to go for it. He takes the action, add butter. And hey, not bad. The steak sizzles, the kitchen smells great, the environment gives him a small positive reward. Things are going well. Now this next part is the most important step. The rookie doesn't worry about what he's going to do next. Instead, he looks at his notebook for the new state he's in, sizzling steak, and he finds the action with the highest possible score. He's asking, what would a master chef do from here to get the best result? This is that max part of Q-learning you might have heard about. And this is where the light bulb goes off. The rookie thinks, wait a minute, the score in my notebook for adding butter was just a 5. But I now see that this move leads to a place where the best possible next move is worth a 9. My old score of 5 must have been too low. I'm going to update it, nudging it up a little closer to that 9. You see what he did? He's correcting a past guess based on better information he just got about the future. That, right there in the kitchen, is temporal difference learning. So after going through all of that, what's the one thing you really need to remember? Let's boil it all down. Here it is. Q-learning teaches an agent how to make master-level decisions by watching its own rookie mistakes. It learns the perfect way to do things by observing its own fumbles, because it knows that even a clumsy step can lead to a future full of brilliant potential. And that kind of leaves us with a pretty cool thought. The whole principle here is about learning from a different policy. We saw how an agent can learn from a perfect future version of itself. But what if it could learn from the experiences of other agents? From anyone's experience, not just its own. What could you do with that? Thanks so much for tuning in.